Hey Doc, this is Easton Faulkner. I'm going to be working through the three steps of the free radical chain mechanism, and then also showing the percent composition of the products at the end. So we start with um, the first step, which is let me switch pins. This is a bad pin. We're starting with the first step. There we go. I'll make it a little bit bolder so you can see it, because I know my camera's far away. The first step is called initiation. The molecule I'm selecting is, we're going to be working with, I think I wanted to do pentane. So pentane has a molecular structure of 1, 2, 3, 4, 5. Oh, I did one too many of this. And we're doing the chlorination of pentane. So the first step in initiation is we actually don't need this here. We're going to be creating the free radical. This only has to happen once, but we have our Cl2 group in the presence of light, so HV. We have a single hydrogen here, single hydrogen here. We end up breaking this bond and resulting in 2 chlorine radicals, which are very dangerous, but also very cool because they can lead to some pretty awesome reactions. So because we have light here and we have our radicals, there's no need for a radical initiator. Into step 2, which is called propagation. This is actually the product formation of what we're hoping to do in this reaction. Oh my goodness. And the first kind of step in this product formation is hydrogen abstraction. So we're going to take one of these chlorine radicals that we've created, and it's going to become the reactant for this part of our pentane molecule. And we 1, 2, 3, 4, 5, and this can actually happen at 3 different locations to give us 3 different products. So I'm going to write this 3 different ways. With a hydrogen here. Let's do a hydrogen here. I know it's kind of a little bit clumpy. I'm sorry, I can make it give us a little bit more room. Here we go. Hydrogen there, and then a hydrogen here on this middle. So it can react with each of these. In this first one, this is a primary hydrogen, secondary hydrogen, and this one is secondary as well. But this one will lead, we're going to create HCl, and also that we're going to create a new radical. And there should be 3 different types of them, so if you'll just bear with me while I get them ready. So there'd be one here, one there, and one here. Each of these being a radical. This one primary, both of these secondary. And this step of the reaction is known as we said before, the hydrogen abstraction. We're going to continue this on another page. But here, I'm going to copy this for us to use. So the products of the hydrogen abstraction part of the propagation are going to lead into the next part of the propagation, which is the halogenation abstraction, in which some of those Cl to Cl molecules they produce one electron, and then one of each of these is going to give off electron out in space here, and that's going to lead us to another one of these chlorine. Oh my goodness, it's another chlorine radical plus, and this is what our final product would be, primary halogen there, secondary one there, and then another secondary one here on this carbon 3. And this is the end of a product formation, the end of propagation, part of this reaction. Then we go on to our final step. I'll kind of draw a line to show here. Step 3, which is termination. Now we try to avoid this part of the reaction if all possible, because it will immediately shut down the whole mechanism. But this is what we also known as quenching the radicals. So this can happen in 3 different ways. The chlorine radicals themselves can come together and they'll just produce the original molecule that we started with. Any one of these 3, well, I think I still have those radicals from another one. I do, perfect. Any one of the radicals that we produced out of the pentane, they can then react with any of the, I'm sorry, my pen's being weird. They can react with any one of these chlorine radicals. To produce our product, what we're actually looking for, but this is actually a bad thing because it stops the whole reaction. So even though we end up with kind of what we wanted, it's not a good thing because it's going to, here I'm going to give us, though I don't have to rewrite all of it, copy. Because it stops the reaction. So although this is a positive thing in regards that we actually we end up with the product we want, it's not in the way that we want it and the whole reaction stops. And then finally, any one of those, any one of the variations of the pentane radicals, I'm not going to rewrite them all, but I'll just say pentane radicals. Any one of them could pair with the other pentane radicals. To kind of double and make this but attached to any one of the other places. And this whole process is known as coupling. So at the very end, when we're left with our 3 products, and these are the products that we were going for, they often appear in different amounts because, as we can see here, this is a primary halogen secondary and secondary. And we know from chlorine that there is a little bit of preference given to these two, that tertiary products have a 5 abundance compared to secondary with a 4 abundance, and primary to a 1 abundance. So given that we have 2 of our products are going to be in that 4 abundance, and 1 of them is going to be in the 1 abundance. So that is 2 times 4 and 1 times 1. Which means 8 parts to 1 part. Which leads, so this out of the total parts, that would be 9. So 8/9 of our products are going to be either these 2, which are both secondary, or and 1/9 of them is going to be this primary. And we can break this down further into 4/9 being this product, 4/9 being this product, and 1/9 being this product. Thank you so much for watching. I appreciate all you do for us.